And welcome to another video. In this one, it's going to be a fairly quick video. We're just going to have a look at one particular example of piecewise function, and that is the absolute value function. So that looks like f of x is the absolute value of x. And what does that really look like? So as a piecewise function, we define it as negative x for x is less than 0, and x for x is greater than or equal to 0. So if we sketch it out, and that would be my biggest tip, whenever you have piecewise functions, always draw them out, as it will be much easier to understand the question. So negative x is really a line at a 45-degree angle in the negative direction, right? So that's y equals negative x. For x is less than 0. Now remember, this is 0, so there's actually a hole here, right? There is a discontinuity here. It is not defined at this point. However, it is defined over here for x is greater than or equal to 0. So that will be like this. So that is y is equal to x. Now, at x equals 0, there is a point change. So what we can see is that it is defined at x equals 0, right? So because f of 0 is 0, right? If we put the absolute value of 0, that is 0. So is it continuous? Yes, it is continuous. And the other reason that it is continuous is because the limit is the same from both sides. Remember our definition from previous videos. The limit as x approaches a for a function has to be a at that point. And what we can see is that over here, the output of the function is 0 when we approach it from the left, as well as when we approach it from the right. So we can see that the limit approaches the value of 0 from both sides. So it is one continuous, right? That's very important to note that this function is continuous. However, the next question is it differentiable? Is it differentiable at that point? And the answer is no. Okay, it is not differentiable at x equals 0. So have a think about why that's the case, and then we will continue in the next video.